Assalamualaikum. My name is Muhammad and my friend name is Ahmad Mifzal Hazem. Today we would like to present on NGL Recovery and Treatment. Introduction. Natural gas, or known as NGL, is a process of removing heavy hydrocarbon liquids from the natural gas stream. These heavy carbon liquids, commonly referred as natural gas liquid NGLs, where it includes ethane, propane, butane, and natural gasoline. Since NGL have greater value as separate marketable products than as part of the natural gas stream, lighter NGL fractions such as ethane, propane, and butane are sold as fuel or feedstock to refineries and petrochemical plants, while the heavy portion is used as gasoline blending stock. Demands of NGL. Recovery of NGLs has provided additional revenue since the supply of NGL has spread over North America with the rapid development and application of shale fracking. The recovery of NGLs has resulted in greater income, where the United States has shifted from a net importer to an exporter of NGL. In 2015, global demand for NGLs exceeded 410 million metric tons, accounting for around 93.6% of total output of over 438 million metric tons. From 2010 to 2015, demand increased at a 3.43% annual rate from 364 billion metric tons. Over that era, the worldwide growth rate of LPG, the most in-demand NGL product, was 3.22% per year, above the growth rate of total petroleum consumption, approximately 1.6% per year. The two main producing regions of NGLs are North America with approximately 31% of overall output, and the Middle East approximately 30% of total production. Principal technique. There are two principal techniques for NGLs. The first one is absorption process and cryogenic process. Absorption process. Absorption method of NGL extraction is a similar process compared to the absorption dehydration process, where glycol is used to absorb water, while absorption in NGL extraction and absorbing oil is used to absorb heavy hydrocarbon. This absorbing oil has a great affinity for NGLs, similar like glycol has an attraction for water. The oil is referred to be lean absorption oil before it has taken up any NGLs. Usually, absorption method is used to extract all the heavy NGLs. The figure shows the basic schematic diagram of absorption process. Absorption process. As natural gas passes through an absorption tower, it comes in contact with absorption oil, which it absorbs a large amount of the NGLs. The rich absorption oil, which contains NGLs, will leave the absorption tower at the bottom. During the process, the absorption oil, propane, butane, pentane, and other heavy hydrocarbons are mixed together. Then the rich oil is fed into lean steel oil still, where it is heated to high temperature of the boiling point of NGLs, but at a lower boiling point of the oil. After that, the NGL product is recovered on top and lean solvent at the bottom. This technique recovers around 75% of butanes and 95 to 90% of pentanes and larger molecules from the natural gas stream. The second technique is cryogenic process. Cryogenic method is a process to extract lighter hydrocarbons such as ethane, as it is difficult to recover from the natural gas stream. There are several methods for cooling the gas to this temperature, but one of the most successful is the turbo expander technique. The figure shows the basic schematic diagram for cryogenic process. Cryogenic process. In this process, external refrigerants are utilized to chill the natural gas stream. The chilled gases are then rapidly expanded by an expansion turbine, causing the temperature to decrease dramatically. The rapid temperature reduction condenses ethane and other hydrocarbons in the gas stream while maintaining methane gases. This method recovers 90 to 95% of the ethane initially present in the gas stream. Furthermore, the expansion turbine may use part of the energy generated when the natural gas stream is enlarged to recompress the gaseous methane effluent, minimizing energy expenses connected with ethane extraction. Extraction of NGL from natural gas stream resulting in both cleaner, purer natural gas and the valuable hydrocarbons that are the NGL itself. Advantages and limitation. For absorption process, the advantages are able to remove heavy hydrocarbon, low pressure drop, and the limitations are high energy consumption, require large equipment and physical spaces. The second one is cryogenic process. The advantages is high product recovery, and the limitations are complexity of control system, high energy consumption, water must be removed to avoid hydrate formation. There are two treatments of natural gas liquids in the natural gas stream that has been identified. The first one is the liquid must be extracted from the natural gas. The second one is the natural gas liquid must be separated themselves down to their base components.
There are a lot of new modern method NGL recovery in this era. In this slide, I'm going to present two new modern method NGL recovery, which are dual column reflux process and flow trap twin reflux absorption process. First is dual column reflux process. This is a quite common process in NGL recovery units. First column acts as absorber to recover the bulk of the NGL components. Second column acts as de-ethanizer during propane recovery and demethanizer during ethane recovery. Addition of reflux for high propane recovery, which can achieve over 99% propane recovery. It is using a very low energy consumption. This slide shows the basic schematic diagram of dual column reflux process. I'm going to show how the process of dual column reflux process. First, the feed gas about 1000 psig been dried by molecular sieve dryer and cooled in a feed exchanger, which is BAHX. Then, the absorber overhead vapor, cold separatory liquid and the absorber bottom are chilling the feed gas. A turbo expander will generate refrigeration by expanding the separator gas to the absorber that usually operate at 450 psig. Propane refrigeration usually being used as supplement to the cooling requirement when processing a rich feed gas. The absorber bottle liquid is pumped by the bottom pump to the ethanizer that operate in higher pressure than absorber. The ethanizer overhead being cooled by using propane refrigeration. A rich C2 liquid being produced to act as reflux to the ethanizer and absorber. Lastly, the absorber overhead being used to cool and condense the absorber reflux stream in lowering the temperature of reflux for separation process. Next, modern technology is flow trap, which is twin reflux absorption process. This has been developed by Fluor, which is engineering company. It is to overcome the dropping of propane recovery, which can lose in liquid revenue during ethane rejection operation. It can be operated in ethane recovery and ethane rejection while maintaining high propane recovery. It can recover over 98% propane during ethane rejection. This slide shows the basic schematic diagram of flow trap process. It shows how the flow trap process been conducted. First, the feed gas been chilled using the cold residue gas and propane refrigeration during ethane recovery operation. The feed gas been separated in the cold separator. About 30% of the expanded drum vapor been subcooled in the absorber subcooler that will produce a subcooled reflux stream to the absorber. Next, the remaining being expanded across a turbo expander to produce the refrigerations. A bottle liquid enriched in the C2 plus liquids being produced by the absorber were routed to the second column. The second column will operate as a demethanizer, will strip the methane content to the Y-grade specification during ethane recovery. The methanizer overhead vapor routed to the bottom of the absorber, which ethane content was reabsorbed. The methanizer reflux system was bypassed. Then, the second column acts as the ethanizer during ethane rejection. The ethanizer overhead vapor that reached with ethane stream routed to the absorber subcooler to form an absorber reflux stream. Lastly, the ethane-rich stream absorbed the propane content from the feed gas and recycled back to the ethanizer. As the conclusions, NGLs were considered to be a byproduct of natural gas production. NGLs are produced when natural gas is processed for delivering to market. The expansion of shale natural gas production has a direct influence on the supply of NGLs. NGL recovery from natural gas is an industry that combines several methods, equipment types, and operational limits. To handle complicated challenges, NGL operations need ongoing technological innovation and adaptability. That's all from us. Thank you.